Okay, hello, Pak Sandro. Today we're going to talk about Flywheel, and these are the group members, which is Muhammad Musyaffa, myself, Aditya Dharmawan, Edensio and Rubben. So here are the table of content. We're going to talk about the Flywheel, principle of work, and application of a Flywheel. Okay, introduction. So a flywheel is basically a wheel which can be used in a machine, which its main purpose is to store energy in a rotating mass. It can obtain a shaft which is attached to a rotor and a motor which allows the flywheel to rotate so that it can harvest any energy which is supplied more than it is required. The stored excess energy can be released again to supply power whenever it is needed or necessary. The flywheel itself can be a heavy metal wheel, but however, the speed may be limited by their ability to restrict the high centrifugal forces. The inertia moderate fluctuations the speed of the engines and strokes excess energy. The flywheel itself is a relatively small device, but it can deliver large amounts of energy depending on how it is manufactured or how it is used.
Um, okay, to get into more detail about the flywheel can be applied on machines for energy restoration. They can be heavy metals. However, the angular speed of the flywheel is limited to resist the high centrifugal forces. A flywheel can be used for many applications, hence having multiple function. In a vehicle, it smoothens the vehicle by reducing the speed and the power capacity on the main powerhouse. It is also useful on electric vehicles since it reduces the necessary duration for recharging in a station. Next. Okay. A flywheel is usually composed of two material, cast iron and steel. The purpose of a cast iron is its cheap manufacturing cost and its ability to absorb vibration. However, it has a poor tensile strength, hence why it's combined with the steel to increase its tensile strength and corrosion resistant property. And there are four different types of flywheels: solid disc, rimmed, high velocity, low velocity, in which solid discs are the mainstream type of flywheel which can be found today, which is composed of cast iron. The solid cross-section structure provides better strength and stability. Rimmed is a type of flywheel which undergoes wear at low RPM and ideally is applied at low capacity engine that outputs high torque and low velocity. High velocity is a flywheel which has a lighter mass since they rotate at a high velocity. It obtains magnetic bearing and requires less maintenance. The range of high velocity is from 30 to 60,000 RPM. Low velocity is a flywheel which is relatively higher since it's bulky. They require more maintenance as it does not use magnetic bearing. The range of low velocity is usually less than 10,000 RPM. Okay, the structure of the flywheel is usually composed of six components: flywheel cover, spring, planetary wheel, axle and radial bearings, support disc, sliding shoe. The purpose of the flywheel cover is the structural casing of the flywheel that is rigid. It rotates along with the flywheel to protect against external barriers. Spring acts as a damper for sudden vibration to protect any sudden occurrence of jerks. Planetary wheel, which is situated with a planetary gear. Axle and raiding bearings is what compensates any imbalance in the radial forces. Support disc is what supports springs and other moving parts. Sliding shoe is situated in the inner wall and reduces wear that is caused.
So the basic working principle of a flywheel is quite interesting as it stores energy for the vehicle's usage. Flywheels save the power in the form of kinetic energy. The kinetic energy is absorbed during a stroke and then be delivered on another stroke. It works when the power is available at a variable rate but is then required at a uniform rate. Vice versa, when it is available at a uniform rate but demanded at a non-uniform rate. For instance, the machinery is driven by the reciprocating internal combustion engine. Next. The method which the flywheels work is simple. In internal internal combustion engine, the motor supplies power to the flywheel. The rotating movement of the flywheel causes the piston to rotate and burn fuel in the combustion chamber. Once there exists power stroke, the flywheel will transfer power from the power stroke to the other strokes depending on if it's a two-stroke engine or a four-stroke. The application of a flywheel will balance the crankshaft and stabilize the rotational movement of the transmission system. Now here we have the energy equation, which allows us to determine the kinetic energy stored in a flywheel. And it depends on two variables, which are angle and moment of inertia of mass, denoted by omega and the letter I. From the equation, we can see that more energy is produced if the angular velocity is increased compared to if the mass is increased due to the power order of 2 on the omega. So more energy can be absorbed and stored if the variable that is increased is the omega. Next.
Okay, now for the applications, flywheels can be applied in many machineries such as wind turbines, automobile engines, and advanced locomotive propulsion systems, boost in electric vehicles, and satellites to control directions. So for wind turbines, in wind turbines, the power output is dependent on the wind itself, hence it is bound to obtain fluctuations. So to solve these problems, flywheel storages are used as separate components to outbalance the power of wind turbines. The flywheel system obtains weight inside of the rotor blades, which can be adjusted. These blades are connected stiffly with the rotating masses of the hub. The weight inside the blades are depicted as being mounted on the bar, which connects onto the blade itself, which is within the hub. Then there's a spiral spring inside, which is placed in the blade masses. Then the spring will force the weight towards the center of the rotor, which goes against the centrifugal force, and the spiral springs can be used as an energy storage system. For locomotive propulsion system, the issues encountered in a locomotive is that when using a turbine, it is less efficient than diesel. Fuel economy is dependent on how the turbine is operated. Maintenance for turbine engines are highly dependent on the number of thermal cycles. And a flywheel is introduced to compensate for the limitations that hinder the locomotives from achieving sustained high speeds. The flywheel system can act as an energy storage system which stores the energy from braking. The kinetic energy can be captured and used for traction system and can be used to boost the locomotive. It may also reduce thermal cycles since the flywheel enables short-term load leveling of the gas turbine. And here's a figure of the locomotive propulsion system.
Another function of a flywheel can be used for electric boost, and those technology can be found in race cars today. Today we're going to use the Audi R18 e-tron quattro as an example, which is a hybrid system, and it exists a flywheel per system, which acts as a boost. The process of the system to work is usually during braking. The MGU will receive energy from the braking, and then the stored energy will be transferred back into the throttle every time the driver steps on the throttle. And two parameters control the process, which are the braking intensity and the flywheel accumulator state of charge. Here is a video showing where the energy recovery system is harvesting kinetic energy and where the flywheel is also placed to store the energy, and then the energy is then released back to the engine of the V6 TDI. So in conclusion, a flywheel is a disc-like component which may be applied on machines for energy restoration. There could be many functions of a flywheel depending on how it is used, but it is mainly used for kinetic energy, to store kinetic energy. They can be made by either two of the materials, casting iron or steel, and there are four types of flywheels. The working of a flywheel is the absorbing of kinetic energy during a stroke and can be delivered on another stroke. Here are the reference and the contribution role. Thank you.